Okay, let's jump right into this explainer. Today, we're looking at the massive, high-stakes world of global maritime shipping, and more specifically, the invisible, rigorously designed shield that protects it all. I mean, every single day, a vast web of vessels traverses our oceans, carrying the literal lifeblood of the global economy. And the logistics keeping them, and, our environment, safe, they're absolutely fascinating.
Just picture the scenario for a second. You've got thousands of tons of explosives, highly flammable liquids, and toxic gases all packed onto a single moving ship rolling across the unforgiving ocean. So how does this not result in constant catastrophic explosions or environmental disasters? Well, the answer definitely isn't luck. It requires a bulletproof, globally synchronized system that dictates exactly how every single volatile chemical is packed, placed, and handled.
So here's our roadmap for today. 1. The IMDG code explained. 2. Classifying dangerous cargo. 3. The dangerous goods list. 4. Stowage and segregation. And finally, 5. Essential shipping documents. Let's get to it. Section 1. The IMDG code explained. Let's start by taking a macro view of the overarching blueprint governing every hazardous voyage. This blueprint is the IMDG code, or the International Maritime Dangerous Goods Code. Now, this isn't just some dry, bureaucratic rulebook gathering dust somewhere. It's literally an internationally agreed-upon survival guide. It's tied directly to the UN mandates under the SOLAS Convention for Human Safety and MARPOL for preventing marine pollution. So this code provides the absolute baseline for safely handling hazardous materials over water. Its main goals: enhance transport safety, protect the marine environment, and basically ensure that the products we rely on every day can move without restriction.
And here's a number you should definitely keep in mind. 2. The IMDG code is updated and maintained by the International Maritime Organization every 2 years. Why so often? Well, because the shipping world is incredibly dynamic. Every 2 years, they have to adapt the rules to account for new technologies, totally new synthesized dangerous goods, and safety concerns that pop up from real-world experiences. It really is a living, breathing document. Section 2, Classifying Dangerous Cargo. Let's look at how this code takes a completely chaotic universe of dangerous materials and organizes them into a precise, manageable system. It all starts with classification. The code divides dangerous goods into 9 distinct classes based on their specific properties. We've got Class 1 for explosives, Class 2 for gases, Class 3 for flammable liquids, and Class 4 for flammable solids and spontaneously combustible substances. And this categorization is absolutely crucial because it dictates everything downstream, right? Like what packaging must be used, what can be transported together, and where it can actually sit on the ship. Moving on to the rest, Class 5 covers oxidizing substances, Class 6 handles toxic and infectious materials, Class 7 is radioactive material, Class 8 covers corrosives, and Class 9 kind of acts as a catch-all for miscellaneous dangerous substances. Now, there is a major misconception we need to clear up right away. The numerical order of these classes, it has absolutely nothing to do with their degree of danger. Class 1 isn't automatically more lethal than Class 8. They just present entirely different types of hazards. So within those 9 classes, every single dangerous good is uniquely identified by what's basically a universal barcode system. It relies on a 4-digit UN number along with the proper shipping name, or PSN. For instance, kerosene is always going to be UN 1223. Together, these 2 data points mean a port worker in Rotterdam and an emergency responder in Shanghai instantly know exactly what's inside a container. It ensures correct handling and, a flawless emergency response if things actually go south. Section 3, the Dangerous Goods List. Let's see how these classes and UN numbers are actually put to use by the people planning these massive voyages. Right at the heart of the IMDG code is the Dangerous Goods List, and it is built entirely around the number 18. This list is a massive, incredibly detailed matrix spread across the code, featuring 18 columns of specifically coded instructions for every single hazardous good recognized by the UN. Honestly, this is the master key to the whole operation. So how does a shore-based cargo planner actually use this thing? Well, it's a very strict step-by-step process. First, they look up that 4-digit UN number over in column 1. Second, they verify the proper shipping name in column 2. And finally, they read across the remaining columns to find highly specific instructions. Column 5 might give them the packing group. Column 8 gives packing instructions. Column 15 refers them to specific fire and spillage emergency schedules. And column 16, that provides the crucial stowage and segregation rules. It is all right there in the matrix. Section 4, stowage and segregation. Now we transition from the theory of the list to the physical reality of loading a giant ship. And let me tell you, this is essentially a high-stakes, life-or-death game of Tetris. To actually win this game of Tetris, you have to understand the difference between stowage and segregation. These are two terms that get mistakenly interchanged all the time. Stowage means the proper placement of goods based on the ship's actual design. So a planner might see a stowage instruction saying on deck only for something that emits highly toxic gases, just so it can vent safely. Segregation, on the other hand, is the mathematical process of calculating the minimum physical distance required between two incompatible classes. The goal? Preventing a violent chemical reaction. In practice, planners use a segregation table with specific codes to maintain these safe distances. A 1 means away from. 2 is separated from. 3 means they literally must be separated by an entire complete compartment. And 4 means separated longitudinally by an intervening compartment. By utilizing these physical distances and heavy steel bulkheads, planners are engineering safety right into the layout of the cargo itself.
But hey, did you notice that X code from the last step? That X points to a fundamental regulatory mandate from the IMDG code, which states, since the properties of substances within each class may vary greatly, the dangerous goods list shall always be consulted. What this means in plain English is this: never, ever assume two materials are safe to put next to each other just based on general class rules. Even if a general table says it's okay, individual substances might have hidden chemical characteristics that react disastrously, so always check the specific UN number. Section 5. Essential shipping documents. Because, let's face it, a physical system is only as good as the communication backing it up. The crucial point here is that human accountability and a really strict paper trail tie this entire physical system together. The code demands comprehensive documentation. The document of compliance proves the ship itself is legally built to carry specific classes. The dangerous goods manifest shows exactly what is on board and where it sits. The shipper's declaration is a signed guarantee that everything is packed correctly. The MSDS provides emergency responders with critical safety info, and the packaging certificate proves the physical containers passed rigorous UN testing. These are not just bureaucratic hurdles, folks. They are life-saving instructions for the crew and for emergency responders. Of course, all that paperwork is pretty much useless if the physical labels on the containers just wash away in a storm. That's why the IMDG code mandates extreme durability for all physical hazard markings. According to Chapter 5.2, every single primary and subsidiary hazard label must not only be visible and legible, but they literally must be able to withstand a full 3 months of immersion in seawater. This ensures that even if a container somehow goes overboard or the ship takes on massive water, the critical safety information survives the absolute harshest ocean conditions. We've explored the incredible depth of the IMDG code today, from its meticulous 9-class system to the immense planning required to segregate explosive chemicals on a moving vessel. But remember, this code is updated every 2 years because human innovation just never stops. As new technologies synthesize never-before-seen materials for our batteries, our medicines, and our industries, it leaves us with a really fascinating question. What unknown hazards will the IMO have to solve in its very next update? The blueprint of maritime safety is never truly finished. It is always evolving to protect us all. Thanks for joining me on this explainer, and keep questioning the systems that keep our world turning.